In the Zhejiang province of Tang Dynasty, China, in approximately 600 AD, Buddhist monks operating under the physician Tao Hongjing's tradition of applied botanical science became the first people in recorded history to move mushroom cultivation from the forest floor to a managed growing environment. They were not growing food as supplementary forage. They were engineering a protein and medicine system from material that the forest considered waste, fallen timber, decaying bark, spent organic matter, and producing yields of Auricularia auriculajudi, the wood ear mushroom, with a consistency and density that wild harvesting could never approach. By the 10th century, shiitake inoculation on scored hardwood logs was a documented, refined practice. By the Edo period in Japan, it was an industry. The conventional food production system operates on a foundational assumption that protein and produce require land. Large, flat, chemically maintained, expensively irrigated land. That assumption is the load-bearing wall of an entire economic architecture, and mushroom cultivation demolishes it. A spare room, a basement, a converted shipping container. Substrate made from straw, sawdust, or coffee grounds, materials that the agricultural and food service industries generate in vast quantities and pay to dispose of. No sunlight required. No soil required. No growing season. The industrial food chain quietly preferred that this remain obscure. A grower producing 50 kilograms of oyster mushrooms per month from a spare bedroom is not buying produce, not paying into distribution margins, not participating in the supply chain at any level. That grower has, in the most literal sense, exited the system. The system has no mechanism to accommodate that. It has no product to sell someone who has stopped needing products. To understand why mushroom cultivation is so extraordinarily efficient, why it produces more protein per square meter than almost any agricultural crop, you need to understand what a fungus actually is and what it is doing when it eats. A mushroom is not a plant. It does not photosynthesize. It does not require sunlight, carbon dioxide exchange, or mineral soil. It is the fruiting body of a fungal organism whose primary structure is mycelium, a network of microscopic filaments called hyphae, which extend through a substrate and secrete extracellular enzymes directly into the surrounding material. These enzymes, primarily ligninases, cellulases, and hemicellulases, are the mechanism. Lignocellulosic material, straw, sawdust, wood chips, cardboard, coffee grounds, agricultural husks, all of these are composed primarily of lignin, cellulose, and hemicellulose. Dense, complex carbon polymers that the vast majority of organisms cannot digest. The fungal mycelium secretes enzymes that break these polymers into simpler sugars, glucose, xylose, mannose, which are then absorbed directly across the hyphal membrane through active transport and converted into fungal biomass. The efficiency ratio is staggering. A substrate block loaded with 1 kilogram of dry straw, material with essentially zero commercial value, will, under correct conditions of humidity, temperature, and fresh air exchange, produce between 300 and 700 grams of fresh mushroom tissue across 2 to 3 flushes. That is a biological efficiency of 30 to 70%, a conversion rate that no livestock or grain crop can approach. A cow converts approximately 8 kilograms of grain into 1 kilogram of beef, an efficiency of roughly 12%, on land that costs money and time to maintain. The mycelium asks for none of that. It asks only for moisture, darkness, and something to eat, and it will eat what you were going to throw away. The fruiting trigger, the signal that causes the mycelium to shift from vegetative growth to mushroom formation, is a drop in temperature combined with an increase in fresh air exchange and a reduction in CO2 concentration. In the wild, this mimics the transition from the warm, still interior of a log to the cool, airy surface conditions of autumn. In a controlled grow space, it is replicated simply. Open a vent, drop the temperature by 5 degrees, mist the surface. The mycelium responds with the same urgency it has been responding to autumn for hundreds of millions of years. Oyster mushrooms retail at farmers markets and direct to consumer between $20 and $40 per kilogram, depending on variety and market. Specialty varieties, lion's mane, chestnut, king oyster, command between $40 and $80 per kilogram at premium retail. A single shelf unit holding 20 substrate blocks, occupying roughly 2 square meters of floor space, produces between 8 and 14 kilograms of mushrooms per month across cycling flushes. Monthly material cost per unit, approximately $20 to $35. Monthly revenue at conservative wholesale pricing, $160 to $280. No land, no seasons, no supply chain dependency. Scale it to a spare room and the numbers become a livelihood. Source your substrate, wheat straw, hardwood sawdust, or spent coffee grounds, the latter available free from any coffee shop that will hold their daily waste for you. Hydrate the straw to 60 to 65% moisture content. A handful squeezed firmly should release only a few drops. Pasteurize it by submerging in water at 70 to 80 degrees Celsius for 1 to 2 hours. This eliminates competing organisms without destroying the substrate structure. Pack the cooled, pasteurized substrate into clear plastic grow bags. Inoculate by mixing in grain spawn, mycelium pre-grown on sterilized rye or wheat, at a rate of roughly 15 to 20% of substrate weight. Seal the bags. Move them to a dark space at 20 to 25 degrees Celsius. Within 10 to 14 days, the bag will be fully colonized, completely white. Cut 4 to 6 small crosses in the surface of the bag. Raise humidity to 85 to 95% through daily misting. Drop temperature to 15 to 18 degrees Celsius. Within 5 to 7 days, pins will form at the cut sites. Harvest by twisting the cluster at the base before the caps fully flatten. The bag will flush again within 7 to 10 days. The Tang Dynasty monks who laid logs in forest rows were not performing a ritual. They were engineering independence: protein from waste, yield from shadow, food from what others had discarded. The modern system requires your participation to survive. It requires that you need it. A bag of straw, a jar of spawn, and a spare corner of your home, that is all it takes to stop needing it. The mycelium has been waiting 1,400 years for you to remember that.